This session is about testing your own code. That means whatever you have written so far. So we have learned about classes. Before that, we learned about regular expressions, and then before that, we learned about a lot of different things such as for loops, and then if-else conditions, and such things like that. And then also we build modules and things like that for uh, to organize code in certain fashion. And then that was about the developing part. That means you're writing code for to achieve a certain goal. Say for example, if you are trying to parse a file and extracting some critical information out of it, like we did in our COVID exercise. We are just passing through the JSON, and then we are calculating the number of active cases per state. So in such cases, the main motive is just to make that software or make that script to work. And the challenge here is, now how do we test the code? So how did we test the code? That is by just putting the print statement, and then we saw that okay, the code is working as expected. Then we manually calculated, okay, Kerala was some 300, and then maybe in Kerala there was in different districts, Idukki was 300, the Ernakulam was 200, so it makes a 500. So such testing we did manually. So that testing is actually called as manual test. And you cannot, the problem with the manual test is it is time consuming, first thing. Second thing is, um, the people are always changing in the software life cycle. So what happens is, if one person has certain thought in his mind and he has certain test cases in his mind, and then he is testing, and then the other person comes and uh, does the same thing, his thinking is different. So maybe now we need to kind of document all this, and we need to write the test cases, and then we need to uh, after identifying the test cases, we need to write code in such a way that these test cases can be automated. So in a way that automation can happen at various different levels in the software life cycle, that we will see in a while. Okay, so the diagram that you are seeing is about various levels or various stages of software development life cycle. So it all starts from a simple requirement, and requirement comes something like, okay, a user needs to tweet. So that is a simple requirement. So then how do we make that simple requirement into a big software, into a end user software? Is the process is, first you do the requirement analysis, and there is a team which does system design. That means what are the how does the system look like, and how much maybe how much load it can take. Then what are the requirements that whether this helps to realize the requirements. And then what kind of like whether it is distributed system, or whether it's that software is run only on a single laptop, or how many users are going to use that software. So are there any simultaneous operations, such things, all these things come in system design. And then so there are certain people who does system design. So the people who are involved at the requirement analysis are usually business analysts. So they know a little bit of software, how the software is built, and they know how to deal with customers and how to capture the requirements. So those guys do the requirement analysis. So they ask a lot of questions to customers, and then they try to reduce the ambiguity in their requirements, and then they bring it onto the table. And there will be a meeting with a business analyst, and then there are architects, system designers. So they sit together and find out how to satisfy these requirements, okay, at a system level. So then there will be an architectural design. That means what kind of architecture that we can use. Is it like a there are several different kinds of architecture. For example, if we are developing a compiler, so there is a certain kind of architecture. That means text is processed and sent to another module. So if it's a social media or media website, then it's like you need distributed systems where you can store databases in different computers, and then somehow there is a way to fetch those things. So that is distributed system architecture, and there are several architectures. So now for this particular requirement, people decide how should it look like, and then they come up with the architectural design. And then the next stage after you do the architectural design, so they also divide a module into fairly maybe at package levels or at the system module levels. They just divide that, okay, this should contain these modules, and this module should communicate with each other with these parameters. And this is called as interface definition. So people sit together with developers and say, okay, this module takes this input and this is the output that is expected. Okay. So for example, in our example, if a user wants to tweet something, the input is text, and then it should go get into the server. So that's a different module which will handle the server and database and things like that. And then it has to come back to the web, and then get distributed to all the people who are following that person. So that is maybe distribution is another module. So how it distributes, that is an internal logic. But at architecture level, we do not think about what is the logic inside the system. So it is just a breaking down of different parts of the system, and then how they are connected. So that is about architecture. Okay. So after this, what happens is for bigger organizations or a bigger software, a complex software, then there are people find people who can get this done. So we look for people who have specific skills for this. At this level, people decide okay, what kind of language we should use, and what kind of various frameworks, libraries can we use, and build this faster and in a robust manner. So such things are decided at architecture as well as module level. So module level is only at developer level it comes to maybe 3-4 people. So some people are handling database or backend code. So they sit together, and then they know the interface already. So they kind of simulate their environment, and then they develop the software. So at all these stages, that is at your left side. So these are the operations that is happening for development. Okay. So there is also a parallel or a complementary process that needs to happen to make sure that at every stage the requirements that are percolated at that level is realized. For example, if you have a tweet as a requirement at module level, maybe there is a requirement that a tweet should be restricted for 300 characters. Okay. So that can be maybe in the backend code we can handle that, and maybe we restrict that if the tweet is exceeding 300 characters, then the handling is different. So we send an error back to the user saying that, okay, you have exceeded 300, or we don't allow him to type anything more. So that is how we kind of stop him to tweet more than 300 characters. So this is one of the requirements. So this can be tested at a developer level. So while saving the tweet itself, we can write some code saying that, okay, this should not exceed this many characters. Okay. And maybe there is a there is some kind of machine learning or to make it more complicated, machine learning or some kind of artificial intelligence looking for the words which are quite abusive, or which are politically or racially sensitive in tweets, such tweets can be stopped at a certain level. So that could be a different requirement, and that might be handled in a different way and in a different module. Okay, so this all these small modules can be tested in an independent fashion, rather than putting it all together and testing the whole thing, and then losing the track of what is happening inside the module. So at module level we do some kind of testing. That testing is called as unit testing. Okay, so maybe we are writing functions, maybe we are writing modules, and we know what are the functions, we know exactly what are the inputs for those functions, what is the expected outcome. So we kind of simulate it, and then uh, uh, we verify it. So all these things that you are seeing in the right side is verification processes. So at module level we do the unit testing, maybe we send some inputs to functions and then we verify that. At integration level all the modules are integrated, so a lot of people start a lot of modules there are 10 or 20 modules, and then people have their own features at each modules, and then people start putting the code in a common code base. So version control systems such as JIT, SVN, ClearCase, and Perforce. So such um, code control systems or code versioning systems are used to handle the what we call as check-ins of this code. So we store the code in a common code base, and then there is at some point of time testing team picks that code, makes a build out of it, and then they start doing integration test. Okay, so that is at integration level. That means just to make sure that whether the modules are able to communicate to each other, and whether they're working as expected. Okay, so at that is the scope of integration testing. That means whether all the modules are can be integrated and they're talking to each other in a smooth fashion without any problems. Okay, so if maybe if in the backend, in our example, if I am not allowing 300 characters, but at GUI, at the web level, if he is allowing 300 characters, that means there is some disconnect. Then there will be a ticket or there will be a concern raised, and then it will come as a bug, and that needs to be fixed at integration testing. Okay, so that is about communication between modules is identified in integration testing. So at a system level what happens is there could be something like something like performance. So how many users can use this system at a time? So can 100 people use Twitter? Yes, 100 people can use. Can 1 million people use at a time? Yes, it can be used. So what is the infrastructure that we need to simulate that environment? Maybe we need for 1 million users, maybe we need 50-60 computers, and which are talking to each other, which are connected in a distributed fashion, and then there are frameworks which handle these systems. So maybe there are whether these frameworks are working correctly, can they handle it, and what is the like if I tweet one thing, and if I have a lot of followers, maybe 20 million followers, and how long it takes to distribute all these tweets to be seen on each one of their systems. So all these kind of stress testing or system level testing is done at system level. So accept testing is done at requirements. So the guy who bought the requirement, right, he will just show to the customer that okay, he is able to tweet. So now he is not worried about how many load it is taking, how much load it is taking. So for him it is just like, okay, I don't know how many people are going to use it, I don't care. So I guess it should be around millions, so it should be up and running, it should not go down, and I should be able to tweet. That's all. Okay, so that is his acceptance testing. So for him all the pain that we have taken here is not visible, or he's not concerned about it. But to do that we need all these levels of testing, and then that is why the software, as it grows complex, the verification also grows complex, and hence we need a strong testing suite at each level of testing. So the first step towards quality of the program or the quality of the code is at unit level testing, because we are writing, essentially we are writing functions at every step, and then those functions needs to be tested, and then internally the calls of the functions should be tested. So that is done at the unit testing. So this is the first level. So all these things, if you are from testing background, maybe you do some kind of automation, such as maybe you put you use Robo framework, or you use Selenium, or you use some other framework, and maybe you put it into Jenkins, and then you kind of give a feedback, quick feedback. So this feedback and development put together is what is called as DevOps. That means development is going in one line, and operations, that are now various levels of testing, integration, and all this put together in an automated fashion is called as DevOps. Okay, so that is what is happening around in every industry. So the core idea here is to find the bugs quickly. So failing is not a problem. Failing quickly is what we are targeting. Failing, you cannot avoid failure, but quick failure and quick resolution is what we are targeting. So in order to fail quickly, we need to write at the code level, at the unit test level. We need to kind of think of all the cases that can go wrong, and we need to write the code. Okay, so let's take that is about the theory part of testing and unit testing. So let us get into our terminal. Okay, let me exit out of it. Okay, so let us just start with a simple example. Let me call that as so what this function does is it takes input parameters as say A and B, very simple function, and returns A plus B. Okay, so this is our function. All right, so now in order to test this, what we do is generally, so whether this is working fine or not, what we do at a general developer level is I just call this function easy sum, and maybe I pass 3 and 4, and then maybe I will store this in some variable called as sum, and then maybe in order to verify, I will just print that and say sum. Right, so let me run this. Okay, Python sum. Okay, now we can see that the program has finished its execution, and I know that 3 plus 4 is 7, and then I think that okay, these two variables taken together, okay, this function is fine. So now I kind of don't worry about so much of I don't put a lot of effort, so I just check in this code. Okay, so now let us see. Another developer comes maybe this is now a part of a bigger framework. Now let us, just to simulate that bigger framework, let us say I will use something called as calc and then return x and y, return maybe is sum x and y. Okay, so let me save this file as calc.py. So let us just imagine that this calc.py is is aggregation of all the other modules such as sum, easy, or easy sum, and maybe we have multiple other operations like maybe easy multiplication, easy subtraction, something like that. So basic operations are all of different modules. So we created one simple, very simple module which has a function called as easy sum. So that module's name is sum easy. So I will just import it. So just to bring that into the context, import sum easy. Okay, in order to use this easy sum, I should do sum easy dot easy sum. Okay, so this is how I'm using it. Okay, now let us print the value here. Calc 5 and 6. So value is 11 because I know, because these are simple outputs, sorry, simple inputs. Calc.py. Okay, now I know that the values I just passed is fine. So I actually do not know the implementation of this easy sum. Okay, so what I do is, okay, now I have successfully verified that this is fine. Now maybe I will send something like 5 and 6. Okay, let us see what happens. My expectation is actually 11. Okay, and now I got 56, which is wrong. So now what is the problem? The problem is, so input values, actually it is only designed to take integers. Okay, so a plus b integer sum is actually takes as integer and does it. So if you pass a string, both of them are string, then it just concatenates, because two strings can be concatenated with an operator plus. So xy goes as ab, and just 5 plus 6, it just places it together, that's all. Okay, now let us see. Now the guy who is using that library, now he gets crazy and then he wants to test some other values. Now let me see if 5 as an integer and 6 as a string, whether it supports or not. Okay, now the program has crashed. That means there is a bug which is inside this program. Maybe from the requirement, it doesn't matter how the numbers are taken. So number should be taken whether it's a string or it doesn't. For user it doesn't matter. So you should treat it as a finally you need to convert, or you need to find out whether it's a number, and then you need to do the calculation. So that was the expectation for your end user. See, now we have with this test case. So now I have 3 test cases. This is normal test case where I have 2 integers and then I'm just passing it. Okay, I'm happy here. So I come here. So program did not crash, but there is some problem because I'm not getting the expected output. Now I went one more step and did a mix of integer and string. Now you see the program crashed, and whatever the code that I might have written after this, the whole software has crashed. And since we got a traceback and it's not handled, the program execution itself is stopped. Now if you are using this on a real calculator, then maybe the calculator just crashes and goes away, okay, which is annoying. Okay, now the problem is the developer who wrote this code for easy sum, so he or his team have not thought over the various inputs that it might take. Okay, so the first step is to identify what are the various test cases. Okay, so now we have just tested three cases. Okay, so let us try to now handle those test cases. Okay, so let me start write coding code for that. Okay, so if is instance is a inbuilt function which will give me a it will compare types of two objects. Okay, type of a, if instance of a is integer and is instance b is of same integer, only then do this. Okay, else you should throw an error to the user saying that return invalid inputs. Okay, now let us try to run the same program. Okay, now we have successfully handled a behavior of a calculator using making some changes inside the code. That means, see, now we had only one line of code, now it has grown to 4 lines. Say for example, if I want to support, so I get a new requirement. So the new requirement is support numbers as strings. Okay, so now this is a first time we did one line. Now then after seeing a bug, then we supported only integers. Now there is a new requirement saying that okay, maybe you take a string as also an integer. Okay, so in order to find out that do that, what I do is, okay, if this is an instance, do this, or maybe integer, maybe I convert it beforehand, integer a, b, I'm using the same variables. So now this this inbuilt function just takes in any object. If it can be converted to an integer, it will simply convert. Let us see what happens. Okay, now we had got this output. Now we had a new requirement which says that support this as well and this as well. Okay, now let us see what is happening. Now we successfully supported that requirement. Okay, we had a simple code, that is one line code, and now it grew to maybe few lines of code. Then what I was telling was, maybe there is a new requirement saying that okay, support words as number as well. For example, 123 is a number, but maybe it comes as a text, something like 123 or something like 123 23, something like this. If I have to support this, then what do I need to do? I have to go here, and then maybe I want to write a new function, something like def convert text to numbers, and then maybe you take text as input, and then you write a lot of code here, and I'm just to I'll just put pass statement, but idea is the code goes here, and a lot of maybe 10 or 15 lines goes here, because maybe we are using some libraries, and that is fine. So maybe the requirement changes, or maybe the product grows, this becomes a popular product, and now maybe there is we also want to support people who are blind. So for them we need to make use of this calculator, and the input is coming as a voice instead of maybe form or somewhere instead of text. So what we are going to do is we are going to build another function or another module altogether, maybe another package altogether, just to make sure that the voice is heard and processed, and we are extracting numbers out of it, and then we are sending back as a voice, not as a just number or printing on this one. So now the scope of the program is no more just summing up the numbers. That is the easy part. Now the difficult part is adding the features, and then making sure that the previous features, that is the support numbers as strings, support words as well, and to make sure that all these various test cases are not broken. That means if you have a feature which will recognize all the text from the voice, and then it is giving back the voice message saying that okay, the sum of 3 and 7 is 10, and then for some people who are actually typing, trying to put some numbers 5 and 6, they're trying to calculate, it is telling us 56, then it's a mishap. That means the basic program is broken. So now we have successfully done a big feature, maybe the essential feature, the core feature is broken. So how do we handle such cases? Because a lot of people have changed in this maybe couple of years that the product has grown. So how do we make sure that the existing features does not break? So one idea that might come into mind is maybe we write some code here, something like okay, at calc I'll do something like if calc this, if calc something like 5 and 5, return value of that should be equal to 10. Okay, if this is okay, then print okay, else print incorrect. Okay, so these are the values that I am going to hard code in a test file or in a test module. So let us try to just make use of this. Maybe I'll just take this code and maybe I'll build another module which is specifically for testing. Okay, so I'm going to paste the code. I'm going to save this as a test calc.py. So in order to bring those functions into this context, I'm going to import calc. Okay, good. So inside calc.py there is a function called as calc. So in order to call that calc okay, so this is our test file. What I'm trying to do is I'm simply trying to verify if my calculator is working fine or not. So if I give two numbers, that is already known numbers, 5 and 5, it should give 10. Let us try to execute the program. Python test calc. Okay, these numbers are coming from here, that is because we are printing it here, I'll just comment this so that it remains as a module, so it doesn't print anything. Okay, let me execute it once more. Okay, so now I have successfully verified for this particular input 5 and 5. I have verified automatically. That means I'm not manually doing anything here. I'm just printing okay. So maybe in your test file, maybe you dump this and say it is okay. Now I need to do it automatically, in the sense not just printing. It should stop the execution. In the test file, it should stop the execution, telling that maybe I have several test cases here. For example, I will write one more test case. I'll copy all these lines and put it here. And maybe another test case was our original test case, which calculates just taking as two integers, 7 and maybe 3. So 7 and 3 is also 10. Okay, so let us just try to execute this. So this is a test file which is verifying. Okay, these two are okay. So now we have written the code to verify the calculator, but actually we are running the program manually is fine, but in order to verify, we are again seeing the monitor saying that okay, these are okay. If something like I'm specifically trying to fail this, okay, until I see this incorrect, my test is running fine. So all this test module is running fine. And then if this is incorrect, then I say something is wrong, and maybe as a developer, I go back what is wrong, and then go here and look at this function. Then it is not right. Then I look at this core function. So maybe I fix it here. Maybe the test case itself is wrong. Then okay, this should be actually equal to 11. Maybe I fix it. Okay. So just to make it failure, I gave this inputs. But the idea here is we have successfully instead of giving one by one, I can give it. I am writing code to test the code. So this is one way to see. Now let us further shorten it. So there are already some. It is called as assertion. There are already some functions or some keywords which are used for this particular purpose. Okay. So those are called assertions. So assertion is nothing but if it is true, or if it is like assert, if this is equal to 10, then the statement is like it just executes and goes to next statement. If it doesn't, if it calculates this, if it fails this equality or whatever the condition we put here, then it stops the execution. So actually in test code, we make sure that in case of a failure, we try to stop the execution. Okay, so that is our aim in the test code. Okay, so now let us assertion error. Okay, so what is happening? Calculate 10 and 4. Okay, 5 and 4 should be 9. Okay, so now you can see that there is one failure test case, but the test case is wrong. But let us try to make it something like, let us pass okay, this feature is not supported now. Okay, now this is breaking the actual code. So now we got, so since this feature is not supported, it says that is, so it just gives a trace back that invalid literal for int. Okay, so that means in order to pass in order to convert anything to integer, we need to actually pass a number, not any string. So I am going to make this further stronger. That means if is instance a is string or anything else. So for this purpose, I am going to take an example as a string. R is instance, B is a string, tell this guy user saying that invalid inputs. Okay, so now there was another requirement, and so now look at now we executed it. Now there is no problem in the code. Now let's look at this code. So 5 plus 4, when we try to add a string which contains a number and actual string, so which looks like a number for end user, but we do not support this feature yet. So for that purpose, we are just throwing an error saying that okay, invalid inputs only. So output is not equal to 10 because the actual output is invalid outputs only integers. So this is not equal to 10. So the assertion has broken. Okay, so that is how the assert statements work. So now as we have successfully carried out operations automatically, saying that instead of looking at the monitor, someone looking at the monitor, what I can do is I can put instead of print the statements, I can put this into my pipeline, software pipeline, such as DevOps, Jenkins, or whatever the system is. So I can put this program, and if I see this, if it breaks the test suite, then I'm going to raise a concern, and maybe it sends a mail to people who are concerned, and then the actions are taken in a hierarchical way. So that means okay, the developer gets a notification and he sees that something is broken, why it is broken, then then he looks at the code, and then finally he fixes the code, he checks in the code, then finally this gets passed. Okay, so let us take one more example, pass example, just to show you that 6 plus 7 is 13. Okay, it's double equal. Okay, just to show you that it stops the execution. So this is pass, this is failure, and this should be passed, but since the assert throws an assertion error, we have stopped at line number 5, and we have not executed this statement. Okay, so this is one of the ways. So now we what we did was, just to revise, we started from manual testing we had one line of code. Now it has grown to maybe 10 lines because of our change in requirement, and then we try to write some tests, like we used if else conditions. If this is equal to my expected outcome is this, then print this, or do not or print an error, something like that. And then further one more step, we went into assertions, and then we used assertions instead of if else, because we wanted program to stop and raise a flag. So we used assert statements. Now the testing side, maybe we have more requirements. So something like we want to name these test cases. Maybe this test case name is actually something like integer test. Okay, this test case name could be maybe integer int word test. Maybe this one is integer test, int test. Okay, so, and maybe I want to pick I want to group some of the tests. I want to add some more functionality such as logging and things like that. So for all these things, there are already some test libraries which are used widely. So one of the framework is called as unit tests. So what we did is unit testing, correct? That is because we are verifying the validity of this program. Okay, so that is verified, but I need more functionality. So since just like logging, it is also a repeating pattern, so there are very good libraries which does this. So in order to do this in a neat and nice fashion, there are libraries. So let us look at those libraries. One library that is called as unit test. Let us just look at how it looks. The syntax, test Python, okay, not mock, unit test Python, okay. All right, that module is called as unit test, okay. So it is just it is coming from a Python default installation. You don't have to pip install it, okay. So let us look at the features of it, like how do we more than features, how do we use it, okay. Because you just need to know how things work, and you don't have to remember anything. So idea here is you just create a file and import that module, and then you need to create a class, and we create class so that we can bundle the test cases. Test cases are nothing but member functions, and then we kind of call this, okay. So how to run this, I'll just show, and how it looks, how neatly it looks, I'll just show, okay. So we are going to modify our program like new file. I am going to create a new module, and I'm going to just paste this here, okay. So unit test calc.py, okay. So that is my file name, okay. So let me just get rid of all this test calc. Here unit test has a module called as test case, okay. So we need to inherit it. So in the classes, while we are discussing about classes and objects, we discussed that if we send a class here as an argument, so we inherit all the properties of it. So we in order to make use of all the characteristics, that is the reason that we inherit it. Let us look at what are the characteristics later, okay. Now the same functions, same stuff, I am going to just copy this, paste it, and now since this is an integer test, I am going to rewrite it as an int test, because I am passing two integers, okay. Int, and then maybe I will instead of assert, I'm going to call assert equal to, so the method here is not equal, you have to, and maybe this test case I'm going to call this as int word test, self dot assert equals this, and this should match. Let us look at this. Should match. It will fail, but let us look at it how it fails. So let us call this as an int word test, int word. So okay, test is already here. The test is already the prefix of this, okay. So let us remove other functions. For simplicity, let us keep only two functions. I'm going to remove everything, okay. This statement means that if this is run, if this runs as a file, call this. Okay, that means if you use this as a module, that means if you import it in another file, this file should not get executed. So this all the test cases should not get executed. That is why we put a guard saying that only when this is run as a file, run this. So the underscore name is nothing but the namespace name, or uh, uh, where you are running. So that means the name becomes main when you're running on the command line. Okay, so don't worry about this so much. That means if you're running it as a file, use this, or if you're importing it, while importing, as you know, it simply executes all the statement, tries to execute all the statements that are outside functions. So we don't want this to be executed when it is when it is imported. Okay, so that is the reason. So now calc is not defined here, so let us bring that into the context. Import calc. Okay, now what we have done is, from this raw way of testing, we have improved a little bit, of course, from if else condition, but we have further improvement. So further improvement is this. Let us try to run this. The way that this is run is Python -m stands for module. That means use unit test module, and then we give the unit test file. So we execute this. Now let us look at the output. Okay, let me enlarge it. Okay, now we have a test, a name for the test. This statement, unit test Python -m unit test and unit test calc, what it does, it goes to this particular class automatically, and then picks up all the functions which are starting from test underscore. So if I have a function something called as def some function pass. Okay, so this won't pick up this. Let me try to make this correct. Let me, because this is so it is trying to equate between invalid inputs, this statement that we are printing here, and it is trying to equate with 10. So that is why it was failing, and it told that okay, it also gives statistics, how many number of test cases are run and in how much time, and what test cases are failed and things like that. So there are additional features that are supported by this library. So this is also one of the ways which we can do, but we do not have so much visibility such as statistics, how many test cases are run, and what kind of test cases are run. And maybe also there are options something like you can disable this test case while running, and you can also add a group of some test cases and execute only that group. So there are different features in this unit test framework, but for our basic use purposes, so what we do is we just use these functions. These are test functions, test underscore. Just write test underscore and gives any name that you want to give, and then call do your logic, and finally verify it. So usually people the common mistake that people do is maybe they will write test cases and they simply call maybe something like this. Okay, and they do not, if you call it like this, it gives a sense of let me correct this. Okay, this should be equal to this should be equal to this string. Okay. copy paste problem. Okay, copy and then let me paste it here. Okay, now let me try to Python minus m unit test calc, sorry, test calc. What is wrong here? Okay, did I save it? Assertion error, line number 5, test underscore. Okay, here. I did not save it. 5 and 4. What is happening? Assertion. 5 and 4 word test. Something got broke. Is equal to. Okay, so sorry, I'm executing this one. This is the file I should be executing. Sometimes stupid problems come. Okay, good. Now you can see that it tells that ran 2 test cases and it is okay. So this is much better than this. This is much better than what we did putting if else conditions. Okay, like this. Okay, so this printing is worst of them. So instead of printing is just manual testing. So writing if else condition, okay, if we made it a little bit better to automatically verify it, then assertion is better, and there is even better way to do things, which means we have much more control, and we can have actually there are things like you can even put it in a HTML format and things like that. For example, I gave -v as an argument. That means it is in verbose mode. It tells what kind of test cases are running. Test integer, test int word. You can see that some function is not getting executed. That is because the functions should start with test underscore. So our unit test automatically picks up all the test cases which are starting with functions starting with test underscore. And now we have successfully now we can add a lot of test case, and then if this is running always, so say for example our the problem that we are discussing, now we have now there is a requirement to support speech to text and then we calculate and then again convert back to speech. Maybe we have some kind of test cases here, and then we also keep running this as and when the build happens. So in that case, so we make sure that our basic code is not broken. So basic code still works, plus our new features are working. So this is also called as regression testing. That means the previous without breaking any existing features, now we are able to add the features. So this is a very simple just for one simple addition problem. We wrote code about like how many lines, so maybe 10 here, and then maybe 10 let us consider like 3 here, and then test case here, and then maybe here. Maybe we wrote 25 lines of code just to verify this. So but our usual problems are much more complicated. So imagine how much code you must be writing and for especially for verification and for the actual logic. So this unit testing is nothing but code for your code. That means you're verifying your own code with the code. So that is about unit testing. So this is called as unit testing because we are testing at module level. Okay, so that is about unit testing. Okay, that is all I had. Any questions?